Welcome, my dears, to section 1.4, rectangular coordinates and distance formula. So hopefully this is not a new idea, but it might be an idea that you have maybe not fully understood before. So the distance formula is the distance between any 2 points. So let's treat this as the first point, x1, y1, and the second point, x2, y2. Whatever they are, whatever order they are, it doesn't matter. It pretty much is Pythagorean's theorem. Okay, it takes x squared, so the distance between the first and the second, square that, add it to y squared, which is the distance from top to bottom, and then you'll get your hypotenuse squared. The only difference is now I square root both sides. The hypotenuse gets rid of their square because you took the square root, and voila, there is your distance formula. Please be aware of what is positive, what's negative. In between the x values, it's negative. You add those quantities together once they are squared. So let's just try some. Calculate the distance between these 2 points. What I found helpful is actually just labeling it. x1, y1, x2, y2. It does not matter which one is your first point and second point, as long as you keep them together. So let's plug in. Distance equals a big square root. x2 is -1 minus x1, square it. y2 is 1. When you subtract a negative, you add. So because I'm subtracting -2, make sure you do an addition 2. When we simplify, we're going to leave that square root. This becomes -7 squared. This will be 3 squared. Keep going with the square root. 49 plus 9. And that gives you a total of 58 under the square root. If you could simplify that square root, I would ask you to find that largest perfect square and rationalize. But this one you cannot. Number 2, determine if the triangle with these vertices is a right triangle. If so, then find the area of the right triangle. You must be like, oh my gosh, geometry days, I love it. I know, it's pretty fun. Let's first draw our picture and see what we're working with. So let's see. -2, -1, 4, 1, 1, 2, 3, 4. Okay. So -2, -1, this point is A. 4, 1, that point is B. 3, 4 is C. So here is my triangle. And I'm trying to see if it's a right triangle. Well, in order to do that, I need to find the side lengths. Think about the first example we did. In order to find the side lengths, we'll have to find the distance between these 2 points, these 2 points, these 2 points, and see if they follow in Pythagorean's theorem. So let's start here. Let's do AB. So I'm going to color it yellow. I'm finding the distance from A to B, and I'm looking at just these 2 points. Does not matter which point you call your x1, y1, as long as it's the same point. So I'm going to do -2 minus 4 squared, -1 minus 1 squared. I would like to see all this worked out, so please just take time. It's not too bad. Remember, -6 squared is a positive 36. And this equals square root of 40. For our case right now, I'm actually not going to simplify because it will be easier with Pythagorean's theorem. So for this case, here is AB. Now let's find CD. CB, there is no CD. which means I'm going to use these 2 points. So I'm going to do 4 minus 3. Those are my x values, y values. Not too bad, 1 plus 9. So CB, that purple distance, is root 10. And we have our last side length. Please take a moment and you find the side length of AC. Hopefully you did it correct. AC should actually be the square root of 50. If you did not get that, please go back and check that you used A and C, and you subtracted your x values, squared them, and added your subtracted y values that are squared. Well, now that we have our picture and our side lengths, kind of makes sense that the longest side is root 50. So that's going to be our hypotenuse. So I'm checking to see, check if a right triangle, that means I take one of my side lengths, so root 40 squared, plus my other side length, which is my purple, and see if it's equal to the hypotenuse squared. I know it's the hypotenuse because if you looked at the picture, this kind of looks like it would be a right angle. And the hypotenuse is always the longest side. So we know that that one's on the right side by itself. So simplifying, square roots cancel, you get 40. Square root and square cancel, you get 10. And look at that. 50 equals 50. Woohoo! So yes, you are a right triangle because it follows Pythagorean's theorem. It said if it is a right triangle, then we'll find the area. So remember, area of a triangle equals 1/2 base times height. 1/2, the base is going to be root 10. The height is root 40. We always look at a triangle, base, height is what's perpendicular to each other. In this case, we get 1/2 square root of 400. Square root of 400 is actually 20. Sorry, falling over here. Area is really 10 units squared. Always have units, and because it's area, it is squared. Hopefully this is not new, but if it's a little refresher and a little help, that's what we care about. We also have something called the midpoint formula. The midpoint formula is how to find the middle of 2 points. You take x1, y1, x2, y2, and instead of finding the distance, we're actually finding what's in the middle. It's a fabulous formula, and let's jump in. Given the points P is -4, 0, Q is 5, -3, and they're endpoints of a circle. So again, some geometry. You're probably like, yes, I loved this. So here is the diameter endpoint. Here's another diameter endpoint. And because it's the diameter, it's telling me it's going through the center. That's extremely important. We want to find the midpoint. So here we go, part A, midpoint formula. Follow it right here. It doesn't matter which point you call x1, y1. I'll just start with -4, 0. So this is my x1 plus my x2. It's a point, so remember it's going to be a coordinate point. And then 0 plus -3 over 2. Simplify that, you'll get 1/2 -3/2. That is the midpoint. That's this point right here. 1/2 -3 over 2. and try to make sense of that. Between -4 and 5, does 1/2 live? Yeah. Between 0 and -3, -1.5? Definitely. Part B now is asking for the radius. 2 ways to find this radius. You can now do the distance between your center to endpoint and find R. Really nice. Or you can find the distance of the diameter and divide by 2. Totally up to you. For my radius, I'm just going to do center to endpoint. Actually, no, let's do diameter. Let's just have fun. So radius equals half the diameter. I'm going to find this whole diameter and cut it in half. So diameter, plug in your endpoints. Make sure you do plus minus. Let's go through these steps here. -9, 3, don't forget they're squared. Keep in mind that's the diameter. There we go. So in order to find what the radius is, we have to divide by 2. This is really 3√10 when you simplify that radical. And now I have to divide it by 2. Therefore, my radius, as weird as it looks, is 3√10 divided by 2. The last thing that might be a little new to us is the equation of a circle. The equation of a circle is x minus the center. So usually you can call this h. Y minus the center equals the radius squared. Okay, HK is the center. So plugging into that formula, I take x minus my center point of 1/2, square it, plus y minus my center point, and since it's already negative, make sure you do a plus sign, and it equals the radius squared. Well, the radius we got from part B, and then I need to square it. Feel free to just type that in your calculator if you want, or leave it like that. You also can distribute that square symbol to each term. I'm going to be very flexible on what you like the best. So here is overall answer. If you put it in your calculator, make sure you can get that. Sometimes people have a hard time typing it in, but that would be your answer. So hopefully this was a good review. If you have questions on distance or midpoint, please let me know. And I do expect to see all the algebra involved. Good luck, my dears.